In this tutorial, I'll show you 5 examples on how to calculate the number of possible combinations. Let's start with a bit of theory. The number of possible combinations if R items are taken from N items is shown as this mathematical formula, where you have N choose R is equal to, at the top we have N pick R, and we did permutations in one of our previous videos, divided by R factorial. And we have the formula for n pick r. If you substitute it into the numerator and divide by r factorial, you'll end up with this. Let's start with question number 1. From a group of 10 physicians, in how many ways can 4 people be selected to attend a conference on acupuncture? So here we have an n value of 10. That's our pool of physicians, and 4 are being selected in no particular order. Remember, that's one of the big differences between combinations and permutations, that order doesn't matter in combinations. So let's substitute these values. We have 10 factorial divided by 10 minus 4, that's 6 factorial, times 4 factorial. Now, of course, we can use our calculator here, but just a quick lesson on factorial. 10 factorial is 10 times 9 times 8 times 7 times 6. And I'll stop at 6. This 6 will cancel out with the bottom one. And underneath we have 4 factorial, which is 4 times 3 times 2 times 1. And if you put this into your calculator, you should end up with 210 possible combinations. Let's move on to question number 2. In how many different sampler dishes with 3 different flavors could you get at an ice cream shop with 31 flavors? Once again, we have an n value of 31, and we're selecting 3. We substitute this into our formula, where we have n choose r, or 31 and 3 is equal to 31 factorial over 28 factorial times 3 factorial. I subtracted 31 from 3, I ended up at 28. Now, if you substitute this into your calculator, you should end up with 4,495 possible sampler combinations. 4,495. Let's move on to question number 3. In question number 3, to win the lottery, 7 out of 50 total numbers need to be selected. In how many ways can 7 numbers be selected? Our n value is 50, r value is 7. Substituting this into our formula, 50 choose 7 is equal to 50 factorial. 50 minus 7 is 43 times 7 factorial. Using our calculator, and this time I'll actually show you a function on the calculator that you possibly have, and it's right here. You type in 50, shift, and the C appears. The R value is 7, and we end up with 99,884,400. Now, of course, don't be confused. This doesn't tell you the probability of getting the 7 numbers that you've chosen. This just tells you the number of ways that those numbers could appear if 7 are chosen from 50. Let's move on to question 4. A ballet choreographer wants 18 dancers for a scene. In how many ways can the choreographer choose the dancers if the company has 20 dancers and if the company has 24 dancers? Of course, for A, we have 2 scenarios. Using your calculator, and we can do that right now, you should end up with the following. So the first one will be 20 choose 18. So we have 20, shift, this button, 18. We end up with 190. And for this, we have this number becoming 24. And that number jumps to 134,596. So let's interpret this. The choreographer could choose from 190 different combinations of the 20 dancers, and when n is increased to 24, with 4 additional dancers, the choreographer can now have a choice of 134,596 combinations. In question B, we're asked, how would you advise the choreographer to choose the dancers? Now, of course, this is subjective. From part A, you can see that it would be impractical for the choreographer to try every possible combination. Instead, the choreographer could use an indirect method, such as a sampling technique, and try to decide which dancers are least likely to be suited for the role. Like I mentioned, this is subjective. Finally, in question number 5, We're asked, Melanie runs a small landscaping business. She has on hand 12 kinds of roses, 16 kinds of small shrubs, 11 kinds of green seedlings, and 18 kinds of lilies. In how many ways can Melanie fill an order if a customer wants A, 15 different varieties consisting of 4 roses, 3 shrubs, 2 evergreens, and 6 lilies, and B, either 4 different roses or 6 different lilies? Let's start with question A. The order in which Melanie chooses the plants does not matter. That's important, so we are dealing with combinations. The number of ways of choosing the roses is 4 from the possible 12. So we have, for the roses, 12 and 4. For the shrubs, we have 16 different kinds. 16 choose 3. Evergreens, we only need 2, and there are 11 kinds. And lastly, for the lilies, we have to choose 6 from a total of 18. If you substitute these into your calculator and find an answer, you should end up with the following numbers. Those are the outputs that I end up with. And from here, you can actually apply the fundamental counting principle, which we did a video on recently. And what the fundamental counting principle told us was that the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So this can occur 495 times. And then we would have to choose the shrubs, and that occurs 560 times. Technically, we would have to multiply this number to this number to this number, and then to that number. If we do that, we'll end up with 495 times 560 times 55 times 18,564. 2.8 times 10 to the power of 11 combinations. 2.8 times 10 to the power of 11 ways of choosing the plants for her customers. Once again, question B reads either 4 different roses or 6 different lilies. The key word here is either. That's important, because what that tells us is that Melanie's customers want either the rose bushes or the lilies. So you can apply the additive counting principle to find the total number of possibilities. So we'll find out what 12 choose R is and what 18 choose 6 is, and add those combinations up. And that number will represent in how many ways either roses or lilies can be combined. Using our calculator, 12 choose 4 plus 18 choose 6. And we get 19,059. And there you have it. That is how to calculate the number of possible combinations.